Hi everybody, this is Kat, and I am here to discuss the electricity and compounds lab. So I'm going to do my very best to sketch out our lab setup as I talk about it. I will fill a couple of different things in. So as you saw in the video, or as you did in class, we used a Petri dish that had copper 2 chloride solution in it. And that copper 2 chloride solution, we saw and observed that it was a liquid. It's like aqua, I would say aqua blue in color. And it's different than the copper 2 chloride solid that we had. We're going to say this is CuCl2. This is aqueous. That's our solution. Our copper 2 chloride solid was greenish in color. I'm going to draw that over here. It was particulate. It was like crystalline, I think is probably a better way to say that. It was also in a Petri dish in the video, and this was CuCl2 solid. Okay. Another thing that we tested before we did the actual electrolysis was the conductivity of these two versions of copper 2 chloride. So when the conductivity meter was placed into the solid form of copper 2 chloride, it did not conduct electricity, and we saw that because the light did not turn on the meter. But when the same conductivity meter was placed into the solution, we had the lights turn on, showing that the solution form will conduct electricity, but the solid form does not. Okay, so let's make a note of that one here, that it conducts electricity, and this one does not conduct. Okay, great. So our electrolysis setup was similar to what we did first semester with the electrolysis of water. So here is my 9-volt battery. That is our source of electricity, 9 volt. And we used wires to connect to our electrodes. The electrodes in both of our electrolysis labs were pencil leads. So there are my electrodes. And then these were each connected with wires. Color of the wire is not important, but I am going to match this to what you saw in the video. The electrode that was on the left-hand side in the video was connected with the red wire, and the electrode that was on the right-hand side as we were looking at it was connected with the black wire. Okay, so once the electricity was connected, we should have seen some evidence of a change taking place. So there were two main things that we saw. The first one was visible as it was happening, and that was the formation of bubbles around the electrode on the right, connected with the black wire. Okay, so this is the formation of a gas, right? That is a clear sign of a change taking place. And that is a sign of a new compound being formed, which means it's going to be a chemical change. So let's also make a note of that. So this is going to be a sign of a chemical change. Okay. Once this second electrode was taken out of the solution, it was more easily observed that a change took place on that electrode as well. And there was a brownish orange solid that formed on that electrode, which was the formation of the copper. Let's just use that brown color. So copper solid formed. Okay, this is also the sign of a chemical change. Abbreviate that there since I'm running out of room, because we had a new substance that formed. Okay, so let's talk about what is really going on here. Okay, I'm going to use some particle diagrams to help us think about what's happening in the solution form of copper 2 chloride compared to the solid form. And this is what is really important for us as to where we're going next with all of this. So let me clear some space. And let's see here. I'm going to try to color code the best that I can. So I'm going to start with the copper 2 chloride solid. And I want to draw this with particles. So this is a solid. I'm going to start with just one particle. I'm going to use different colors. Let's see here. I'm going to use orange to represent my copper. And then I'm going to use a green color to represent the 2 chlorines. This doesn't have anything to do with the color of the solid that we saw, okay, but that's what I'm going to choose to use. So I'm going to show you not only with color, but with my labels on there as well. Okay, these are bonded together. We have a compound. We can see what's happening. If we know that this is a solid, we're going to have multiple particles of this compound that are going to be put together to give us our sample. All right, so if we're looking at the copper 2 chloride, which is the aqueous solution, the difference is what is happening with those individual particles. So we know that something has to be different. It's not just because one is a solid and one is a liquid, but there's something else that's happening that makes it possible for the solution form of copper 2 chloride to conduct the electricity. So one of the things that happens here is that, as we can see in the electrolysis that occurs, the copper and the chlorine are separate, and once the electricity is applied, they deposit or form the gas on either of those electrodes. But those two pieces, the copper and the chlorine, wind up being separate in the solution form as well. So if I show my copper and my chlorine particles as being separate, there's something else that has to be happening there, because I know that when I had the copper 2 chloride, I didn't see solid copper and I didn't have chlorine gas already. So the thing that allows electricity to conduct through a substance has to do with the fact that there are charges present. Okay, there are charges present, and this allows electricity to flow. If you remember, in the electrolysis of water, we had to add another compound in just a little bit to make it so that there were charges present so the electricity could flow. Electricity is just movement of electrons, and so that obviously is going to give us some sort of charge that's taking place. So we'll talk about where these charges come from and how an atom would turn into something with a charge. That's called an ion. But what we wind up with is we wind up with copper having a charge of +2. Let me zoom in on this a little bit. And each chlorine having a negative charge. Okay? So when they are separated like they are in the aqueous solution, we've got positive charges and negative charges flowing through that liquid solution. They're dissolved in water. Okay, that separation of the positive and negative charges is what allows the electricity to flow through. And that electricity provides enough energy to separate the copper and the chlorine into the individual elements. Okay, now the copper and the chlorine still have these charges when they're in the solid form. Okay, +2 and -1. Okay. But the difference is that they are combined and give me one neutral compound instead of separate individual particles with charges, which we call ions. Okay, so We've got a lot of stuff that's happening in this simple little experiment that just took a few minutes. Um, we have evidence of a chemical change. Okay. We have evidence of separation of particles in the solid form compared to the solution form of the copper 2 chloride. And the fact that the electricity flows through the solution form and allows the electrolysis to take place, those are going to be evidence of the fact that charge is present. Okay? And this idea of charges and ions is going to lead us right into our next big topic, which is going to be chemical bonding and more with compounds. We can also circle this back to definite and multiple proportions. If you remember, one of the examples that we did when we were figuring out definite and multiple proportions was to find the formula of two different compounds using copper and chlorine together. Okay. One of those was this copper 2 chloride compound that we used. The other one was a different version, which is copper 1 chloride, which has a completely different formula. Okay. So there's a lot happening in this little lab, going forwards, going backwards, taking it full circle. So please make sure that you have written down some things about this conclusion for this lab, as it's going to be really important as we move forward. And if you have any questions, make sure that you reach out to your chemistry teacher so myself or your teacher can get those questions answered. Thanks. We'll see you soon with another chemistry video.